And again, once you have computed the gradient, then you just like update all the gradients. And again, it's a simple one line. It's optimizer.step. Okay, so let me quickly go through this. So you know that when you have computed gradients, it's fine. But what will be the equation to actually make that update for each parameter? What we studied was stochastic gradient descent, that equation which was using learning rate or maybe momentum, right? But there are a lot of other optimizers out there. So you will have to define the optimizer, what optimizer you want to use. And for this course, don't worry about it. You can just use SGD for all the assignments. And there are a lot of other variations as well. Okay, so this is actually defining a very simple stochastic gradient descent optimizer. And the parameters are like all the parameters of your network. And this will actually return all the trainable parameters of your network. And this is a learning rate. And as I said, like this is a very important factor in your optimization step. And again, this is something, there is no formula to actually get this value. You will have to empirically determine this value by running multiple experiments. Okay, and this learning rate is something which is very important when you're defining your optimizer. So this is just SGD, but you can define other optimizers as well, as I said. And I think we have some optimizers where even you don't have to worry about the learning rate. So that optimizer can automatically figure out the learning rate for you. And of course, when it might not work like for all the scenarios, but we do have those options as well. All right, so once we have the optimizer, so when we are designing SGD, what it's doing is, so you remember that equation, right? You have the current value and you subtract like the learning rate times the gradient. So it's just defining that simple equation, nothing fancy. All right. So this step is you will have to first, so this is just like making the gradient value 0, because inside your network, you have a lot of trainable parameters, and to store the gradients for each parameter, you have some variables which will store these gradients, right? So it's just actually making those values 0 before starting. And this step you have already seen. For any given input, you will produce the output. Criterion, you will already have the loss function, which we described before. You will give like the target and the output, and you will compute the loss. And when you call this loss.backward, this is actually computing the gradients. All right. Now, this is the actual training, optimizer.step, when your parameters are being updated. And these parameters will be updated based on that simple equation which we discussed for SGD. We have the learning rate. This step is going to give you gradient for all the parameters in your network. All right. And then this step is actually just updating them all in parallel so that you don't have to worry about it. Okay, so these two steps are actually the core of network training. But again, it's really nice that you don't have to worry about it. You just call these two functions every time. And these two steps are never going to change. In fact, these three steps are never going to change. Okay, whatever network you define, unless we are doing something fancy.